Bismillahirrahmanirrahim. Our today's lecture is about derivatives of exponential functions. So first of all, I will write the formula or the exponential function which is to be differentiate. So y is equal to e raised to power f of x is an exponential function. Now when we differentiate, we have dy by dx is equal to d by dx and f of x e raised to power f of x, which means the function in the exponent we have to take the differential and the rest exponential function will be remain as it is. So as an example, we take y is equal to e raised to power 2x cube. Now when we differentiate, it will be dy by dx is equal to d by dx 2x cube, and the exponential function e raised to power 2x cube will remain as it is. Now the differential will be 6x square and e raised to power 2x cube. This is the derivative of the exponential function. Now let's take few questions. Question number 1, y is equal to e raised to power x 4 plus x plus 1. So when we differentiate it, it will be dy by dx is equal to d by dx x raised to power 4 plus x plus 1, and the exponential function will remain as it is, plus 1. So the differential of this will be 4x cube plus 1 plus 0, because the derivative of constant is always 0, and here we will write the original exponential function as it is. Therefore dy by dx is equal to 4x cube plus 1 and e raised to power x raised to power 4 plus x plus 1. This is our answer. Now question number 2. Here we see that there are two functions x cube and e raised to power x. So we will use first product rule and then we will use the differential for the exponential function. So we have dy by dx, and now applying product rule, which is x cube is the first function, then we will take the derivative of the second function, which is an exponential function, plus e raised to power x will remain as it is, and then we will take the derivative of first function d by dx. X cube into 1 and e raised to power x plus e raised to power x, and this is 3x square. Now this is 1 because the derivative of x is 1, and we have to take the derivative of x, because for exponential function here we have to use y is equal to f dash of x and e raised to power f of x. So this will our formula for the differentiation of exponential function. That's why the derivative of x is 1. So dy by dx is equal to x cube e raised to power x plus 3x square e raised to power x is the answer. Now here dy by dx is equal to d by dx 1 over x and e raised to power 1 over x. So here we will take x as x raised to power minus 1 as we have studied in the derivatives of the ordinary functions. 1 over x minus 1 x raised to power minus 1 and e raised to power 1 by x dy by dx. So minus x raised to power minus 2 e raised to power 1 by x, and finally we can write minus e raised to power 1 over x whole divided by x raised to power 2. This is our answer. Now here we have a trigonometric function and its angle is an exponential function. So dy by dx is equal to d by dx sine e raised to power x. We have derivative of sine, which is cos, angle is e raised to power x, and then we are going to take the derivative of exponent e raised to power x, and we have cos e raised to power x 1 and e raised to power x, as we have used the formula for the derivative of the trigonometric function. So finally we have e raised to power x cos e raised to power x, and this is dy by dx. Now here question number 5, y is equal to e raised to power x into tangent x. So we have dy by dx and d by dx x tangent x and e raised to power x tangent x. Now here we are, first of all, in this portion we are going to apply the product rule. X d by dx, which is tangent x plus tangent x and derivative of x. E raised to power x tangent x. So x derivative of tangent x is secant square x plus tangent x and derivative of x is 1. So here our differentiation is now complete and we are just going to simplify it. It is x secant square x plus tangent x and e raised to power x tangent x. So this is our answer. The questions in this topic are very easy and simple if you remember the derivatives of the simple functions. Now question number 6, y is equal to e raised to power x divided by ln x. Now here we are going to use the quotient rule or division rule. So dy by dx is equal to ln x square ln x d by dx, which is the derivative for the exponential function, minus e raised to power x and then the derivative for the natural log. Now ln x and the derivative of e raised to power x is x, because the differential of x is 1, so we don't write that. E raised to power x and then For the derivative of natural logarithm, 1 over x and derivative of x whole divided by ln x whole square. For the derivative of natural logarithm, you can see or study the topic for the derivatives of natural logarithms. Here we have discussed all these differentials in detail. E raised to power x minus e raised to power x over x and whole divided by ln x whole square. So taking the LCM, x ln x e raised to power x minus e raised to power x and whole divided by x ln x square. So our dy by dx for this function is dy by dx is equal to x ln x e raised to power x minus e raised to power x whole divided by x and ln x whole square. This is our answer. Now question number 7. Y is equal to exp into under root 1 plus 5x square. Now this exp also means that we have an exponential function, and this we can write as y is equal to e under root 1 plus 5x square, and the rest procedures are same. So taking the differential, we have dy by dx is equal to d by dx under root 1 plus 5 x square and e raised to power under root 1 plus 5x square. Now taking the differential, we have 1 over 2 1 plus 5x square minus 1 by 2, and then the derivative of the function d by dx 1 plus 5x square e raised to power under root 1 plus 5x square. So 1 over 2 1 plus 5x square minus 1 over 2 and derivative of 0, which is the derivative of 1, and here we have 10x e raised to power under root 1 plus 5x square. And now finally we are going to simplify and rewrite 2 under root 1 plus 5 x square 10x e raised to power under root 1 plus 5x square. And on simplification further, we get 5x e raised to power under root 1 plus 5 x square over under root 1 plus 5 x square. This is our answer. Now dear students, this was the last question of this topic.